Today we're going to talk about multiplying monomials. But before we get to multiplying monomials, I'm just going to maybe go over some conventions that we do here. So let me take a look at the first question. And it is 3, 4. Now, here's what's in the middle. Is that a multiplication, or is that, in fact, an x? Well, it's really hard to determine. So, for instance, 3 times 4 looks like this, but 3x4 looks like that. Now, they're very, very different. Hold on. The meanings are incredibly different. And so just some things, when we write an x as a variable, we try to make it like a stylized x, which really is the Greek letter chi. But regardless, if I'm going to write 3 times 4, in algebra, often when we want to multiply, we simply put two quantities beside each other in brackets. Now, there's no ambiguity here. What is the operation? Well, there's two brackets beside each other, and really that means to multiply. So 3 times 4 is 12. Or sometimes you'll see 3.4, and that's 12. So dot can also mean multiplication, but there is a problem in which some people might interpret that as 3.4 is equal to 12. So really, we're going to move away from the x. I won't favor the dot to signify multiplication. I'll probably look for brackets and brackets. All right, so we're going to be multiplying monomials. I just want to go over some basic facts of multiplying that will help us multiplying monomials. And the distributive nature of math says A times B times C is equal to C times B times A. So when we're multiplying two or more quantities, order does not matter in multiplication. So for instance, 3 times 2 times 1 is equal to 1 times 3 times 2, which is equal to 1 times 2 times 3. So it doesn't matter which way we order or which way we multiply, the answer is always going to be 6. Now, we're going to be using this fact quite extensively. And it's just a nice organization technique for when you're multiplying monomials. Also, just a nice refresher. Now, let me look. Ooh, all right, I got it. I needed to look. X times X. Now, I'm just going to say I'm going to multiply X times X. Hopefully, you're able to write it as X squared. When we multiply variables, we simply add the exponents. Now, the reason why we add the exponents is really the exponent indicates the number of factors of x there are. And x times x, there's 2 factors of x. So if I have x cubed times x to the power of 2, this would be x to the power of 3 plus 2, which is 5. If you want greater explanation for that, I'm going to denote all the factors of x cubed in blue, all the factors of x squared in red. So why does this happen? Well, x cubed really means x times x times x. X squared means x times x. So altogether, we have 3 factors plus another 2 factors, which gives me x to the power of 5. So really, when 2 variables with the same base, now the base has to be the same, are multiplied, we simply add the exponents. Also, now, just a nice refresher here, maybe let me do 2x times, let's do something crazy, 9x to the power of 6. Well, when I'm doing this here, I am simply going to do this in two parts. And when we're multiplying monomials, we really going to group together the coefficients of the variables. And then now, after that, we can group together the variables. So on one side we have the coefficients, on the other side we have the variables. And I can split this up using that distributive property of multiplication. So really, what do? We are able simply to multiply the coefficients and multiply the variables. And I always encourage people, if it's x, just write it x to the power of 1. Makes things much, much easier. So that was our review. Let me just check if I set up the questions good. I think I'm ready to go here. So we're going to be looking at multiplying monomials.